Welcome to SOLIDWORKS Essentials, designing molded and casted parts. My name is Tandy Banks. I'll be facilitating this course here on Pluralsight. This first module is Introduction to Tapered and Drafted Geometries. Through this module, we're going to learn how to make geometries that might be used as a machined part, where we start with a cast or a forged geometry, and then we'll move on to more complex shapes like something that would be used in the plastic injection molding industry. So what is draft? It's the amount of taper for molded or cast parts perpendicular to the parting line, and it's usually measured in degrees. So why do we need draft? Tapered features are desirable when producing parts through a molding process. We use these to ease the process of separating the mold and the part, and these molds can be very costly. And so we're also looking to increase the life of the mold due to reduced wear because of the taper. And then we also do this in the forging industry to aid in moving material. So I want to take a few moments and illustrate what I mean by draft. So I'll just come in here and draw a pretty basic shape. And from here, we're going to let this represent our parting line. It's a term used a lot when we're talking about molds. And this has to do with the place where the mold splits into positive and negative directions. Negative is not a bad term. It just means that it's opposite of the positive direction. One of the ways that I learned about draft and tapers was from cupcakes. If you've ever noticed, a cupcake tin has tapers in the mold. And the reason why is because we want that cupcake, that delicious piece of cake, to pop out of the mold and not be torn apart, especially when we're pulling a thing straight out of the oven and we want to take a bite. And so this angle, represented by theta, is important depending on the type of geometry and the type of manufacturing process that you're trying to use. So let's say that we were wanting to do something for the plastic injection molding in. So we might use something like 1/2 degree to 5 degrees. Maybe we were going to pour molten metal into a green sand cast mold. Well, maybe we want on a casting to be somewhere between 3 and 8 degrees. And then if we're doing something more aggressive like closed die drop forging, we might want to really open that up and go somewhere between 7 to 15 degrees. Especially on that last one, what we're trying to do is we're trying to take a piece of semi-pliable metal and we're trying to hammer it into place. And so we need to open up that taper or that draft angle as much as possible to be able to grab and pull the material into the mold. We're trying to condense that as every drop of the hammer, we're going to try to pull that material and condense it. But if we get too flat an angle, all we'll do is we'll cause the mold to just flatten the material out and actually squeeze it out into flashing. And so it's a delicate balance between trying to gather the material versus squeezing it out or just hammering it flat. These are not absolute values. They're ranges. They're rules of thumb. They're areas for you to start with whenever you're trying to design your geometry that's related to tapers and drafts. So in the next few examples, you're going to see us employ the draft angle. Remember that that's based off of the vertical. We're going to apply this angle of theta in our draft as we create features. So let's get started, hop into SOLIDWORKS, and get to creating some geometry.